Okay, year 9. So yesterday I had asked you to finish off these questions on 129 onwards, up to I think it was 131. So let's go through the answers now. So question 1, a paving slab 0.2 meters long and 0.15 meters wide weighs 300 newtons. Calculate the pressure it creates on the ground. So if we're making our list of information for this, we know the weight is the force is 300 newtons, and to calculate the pressure we also need the area. So for this one here, because it's a rectangle, then we have to calculate the area based on the dimensions we've been given there in the question. So the area is length times breadth, which is 0.2 multiplied by 0.15. So that gets us 0.03 meters squared. And then we can calculate the pressure. So pressure equals force divided by area. The force is 300 and the area is 0.03. That gets 10,000 newtons per meter squared. And I knew this unit because I've divided newtons by area in meters squared. Okay, for part B, Emma put a plant in a tub on the paving slab. It weighed 90 newtons. Calculate the new pressure on the ground. So our new force is going to be the weight of the paving slab plus the weight of this, a plant. So our new force is 390 newtons. The area is still the same, it's still sitting on the paving slab. So the area is still 0.03 meters squared. So we can calculate our pressure. Now I'm running out of room a little bit here, so I'm going to have to work across the page. Don't tell your maths teacher, especially if I'm your maths teacher. Anyway, that gets 13,000 newtons per meter squared. Okay. Now, I do remember talking to you about this question in class, but as I said yesterday, that was between missing lessons and doing your test. It's been ages from we were talking about this stuff, so it is good to have the chance to go through it all again. So, Ben dropped a box on the floor. The box weighs 80 newtons, so we know that's going to be the force that we are using in our question. It's 1 meter long, 0.5 meters wide, and 0.2 meters high. Before I would start this, I would do a little sketch of my box. Okay. So it's 1 meter long, 0.5 meters wide, and 0.2 meters high. So for part A, what's the area of its largest face? The largest face is going to be the face that has the biggest dimensions. So that's going to be this top one, the way I've drawn it, or the bottom one, which is the 1 meter multiplied by the 0.5. So length times breadth, 1 multiplied by 0.5, 0.5 meters squared. B, what's the area of its smallest face? So the smallest face is going to be the one with the two smallest dimensions. It's going to be this little end bit here. So again, it's a rectangle, so length times breadth, 0.5 multiplied by 0.2 gets 0.1 meters squared. So there's quite a lot of work on it to fit into quite a tight space here, so I'll just underline my answers. Okay, now C, what's the greatest pressure it could exert on the floor? Now, the biggest pressure is going to come whenever it's sitting on its smallest face, because you'll have all that force acting on the smallest area. So we're going to be using, in this one, I'll make our list, the force is 80 newtons. We know the biggest pressure is going to come whenever it's sitting on its smallest face. So the area we need to use in this one is 0.1 meters squared. So then I can do pressure is force divided by area. 80 divided by 0.1 gets me 800 newtons per meter squared. Okay, part D. There we go. The smallest pressure, so again it's still the same weight, so the force is still the same, that's 80 newtons. The smallest pressure is going to come whenever it is sitting on its biggest face, because you're spreading out all that force over as big an area as possible. So the area we need to use here is the area of the biggest face, which we had figured out was 0.5. So pressure is force divided by area. Force is 80, area is 0.5, so that gets us 160 newtons per meter squared. So that's quite the difference in pressure there for the same object, just depending how you set it down, isn't it? Okay, number 3. Jim weighs 900 newtons, so that's going to be the force that we are going to be working with here. So force is 900 newtons. The area of each of his feet is 0.15 meters squared. He thinks it's safe to stand on a frozen pond to reach a ball, and then it tells you the ice can withstand a pressure of 3,500 before it cracks. So is it safe? It's really asking, is he correct in saying it's safe? So if we're assuming he's standing on both feet, then his area is going to be 0.3 meters squared, because it's double each foot. So we'll assume he's standing on both feet. Then we can calculate the pressure. So force over area. Force is 900, the area is 0.3. That gets us a pressure of 3,000 newtons per meter squared. Okay, so is he correct? Technically, yes, if he stands on 2 feet. I still don't think you should do it though. Okay, so 4 is really at the top of the next page. 4a is, why is the head of a drawing pin large and the tip smaller? So that is so that you can use it safely. So with our drawing pin, we have a drawing pin like this. The bit that you are putting your finger or your thumb on is the bigger area, and the reason for that is that you get a smaller force acting on your finger so that you can actually use it and the pin doesn't poke into you, so that you reduce the pressure on your finger or your thumb and it doesn't hurt you. And then the tip, the wee bit that's going into the wall, is a wee tiny area, so you want to be able to create as big a pressure as possible with the same size force that you're applying on the other side. So let's get that written down in a slightly neater way than the way I've just said it. So the large head means we've got a lower pressure, so less pain to the person using it. And the small tip gives you a higher pressure for the same force. So that means it's easier to pierce into the wall. Okay. B tells you the head of a drawing pin has an area of 100 millimeters squared. Calculate the pressure if you push with a force of 10 newtons. So pressure is force over area. 100 over 10 gives us 10. Oh, look, I'm an idiot. I've done those the wrong way around. Give me a second. Okay, let's try that again. So the force is 10, I put them in the wrong way, look. The area is 100, so that gets me 0.1 newtons per millimeter squared. Okay, part C. The tip of the drawing pin has an area of 0.01 millimeters squared, and the force is still the 10 newtons, and we have to calculate the pressure. So pressure is force over area, 10 over 0.01 gets 1000 newtons per millimeter squared. So that's quite a difference again. There's my two answers there for those. Okay, number 5. A car weighs 9,000 newtons. The recommended tire pressure is that. So we've got the weight, the force is 9,000. The pressure is 18 newtons per centimetre squared. And then we have to find the area. So our equation is pressure is force over area. If we rearrange that to make area be the subject, and remember you can use your equation triangle to do that if you want. Try and use your algebra skills though. If we rearrange that, we get area is force over pressure. So the force is 9,000, the pressure is 18. That gets us an area of 500. Now our unit is going to be centimetre squared, because see the way our pressure was in newtons per centimetre squared. That means that's what our area is going to come out in. So 500 centimetres squared. But that is for all 4. So the question had asked the area of each tire. You have to divide that to get the area of one tire. So the area of each tire is 500 divided by 4 is 125 centimetres squared. Okay, number 6. Sally's wearing stiletto heels. Each heel has an area of 0.25 centimetres squared. She steps on Sam's foot with all her weight on one heel, so that tells us the area we're working with is that 0.25 centimetres squared. Always be careful with questions about feet, because sometimes they are both feet and sometimes they're 1 feet, and you need to figure out what to do with the area there. Anyway, the pressure on Sam's foot is 2,000 newtons per centimetre squared. What does Sally weigh? So we're looking to calculate the force. Again, we know our equation is pressure is force over area. Use your algebra to get force to be on its own. So multiply both sides by area and you will end up with pressure multiplied by area. So the pressure is 2,000, the area 0.25. So that means her weight is 500 newtons. Okay. Now, page 131. So circle the correct word or phrase in each bold pair in the sentences below. Pressure is a measure of how much force is exerted over a certain area. If the force applied to a certain area is bigger, the pressure will be bigger. So if you increase the force, you'll increase the pressure. If you increase the area over which the force is exerted, the pressure will be smaller. You can calculate pressure using the equation force divided by area or area divided by force. It's force divided by area. You can measure pressure in newtons or pascals. Not newtons. Remember, newtons is the unit of force. Pascals is the same as newtons per metre squared. So that's one of the units that you can use for pressure. Okay. Use the equation to work out the pressure. So a box weighs 50 newtons. The force is 50 newtons. And its area is 5 metres squared. And we have to calculate the pressure. So pressure is force divided by area. The force is 50, the area is 5. So that gets us a pressure of 10 newtons per metre squared. Okay. B. Another identical box is placed on top of the first box. What's the pressure now? So if there's another one on top, the force is going to have doubled. So it's going to be 100 newtons. But if it's sitting on top of it, the area is still going to be the same, so 5 metres squared. So pressure is force over area. 100 over 5 is going to give us 20 newtons per metre squared. Or you could have had pascals for your units in either of these because it's the same as newtons per metre squared. C. A snowboarder weighs 300 newtons. So the force we're working with here is 300 newtons. Area is 0.5. What's the pressure? So pressure is force over area. 300 over 0.5 gets 600 newtons per meter squared, or pascals. 3. A student is investigating the pressure that a block of wood is exerting on the floor. The weight of the wood is 20 newtons. So my force is 20 newtons. And the block is 10 centimeters long, 5 wide and 2 high. 10 long, 5 wide, 2 high. 10, 5, 2. What is the biggest pressure the block can exert on the floor? So this is like that other question. The biggest pressure it can exert is going to be whenever it's sitting on this wee tiny area here. So the area we're going to be having to use there is going to be 2 multiplied by 5, 10 centimeters squared. So this is just the area of this week, the smallest face, because that's going to give us the biggest pressure. So pressure is force divided by area. 20 over 10 gives us 2 newtons per centimeter squared. And then for part B, what's the smallest pressure that the block can exert on the floor? So the force is still 20. The smallest pressure is going to come whenever it's sitting on its biggest face, which is going to be this one here, which is the 10 and the 5. So area is length times width. 10 times 5 is 50 centimeters squared. Okay, so pressure is force over area. The force is 20, the area is 50. That's going to get 0.4 newtons per centimeter squared. Okay. To save you listening to me talking through the whole of this wee table at the bottom, I'll just fill it in, and then you'll see that filled in a second, and I'll talk about the units and things. Okay, so I filled these all out. The only thing I really need to talk to you once you check your numbers is check that all your units match. So because in this top one, force is in newtons, area is in centimeters squared, that means my pressure is in newtons per centimeter squared. Because this pressure was newtons per meter squared, that meant I knew that that area was in meters, and so on for the rest of them. Okay, so that's it for all the questions. Hopefully you've checked over all your answers. Remember to fill in any corrections as you go, and I don't just mean the answer, fill in the proper solution as well. Okay, so I'm going to upload a separate video for the liquid pressure stuff that's coming up next. See you in a minute.